Hey everybody, it is Brian from quantlabs.net. What you're looking at is probably what I would consider old school photography. Just take a look at those old school Macs. Yeah, this is a very old school, I'm sure. Going probably at least 10 bucks. This is not me. I never look like this. Just a random photo off the net. I gotta pay homage to these kind of guys because these are the kind of guys that pioneer the internet clustering. What I'm about to show you. What you need to realize, there is something called a Beowulf cluster. What is that, and where am I going with this topic? Well, let me show you. Okay, let's talk about clustering. Back in the day, back in '98, bunch of guys got together and built a cheap commodity hardware, a cluster. It's all parallel computing. We've gone on about parallel computing, and this is one of the first generation ones that exist. Now, what intrigued me or led me down this path was something called, and if you've been watching my previous videos, Open MPI. Which is really pioneered by big companies like IBM, Cisco, AMD, ARM, all the big processing companies. Now, for those that are new to all of this, this is how supercomputers are built. This is clustering. And why are we talking about it when it comes to HFT? Well, guess what? This is the crust of what makes HFT happen. High frequency trading. And you see all those nice little racks of servers with their pretty little lights when you turn off the lights. These are them within a cluster. If you take a look at this little photo, this is pretty old school. There you go. That's from McGill, and I believe it's '98. But anyways, that's what Beowulf clustering is. It's coming to Wikipedia. And there's all these other types of clusters that are built off of Beowulf. But Beowulf is the original. And it's meant for either Fortran, C++. It can be used for other languages as well, but we're looking for the fastest on the planet, which of course is C++. Some would argue other than that. Well, good for them. But nonetheless, we're looking at Linux, very low level stuff. Okay, so we've talked about that. For all you tree hugging kind of arty kind of guys, here's how to build your own Beowulf cluster on the cheap for about $3 grand. Okay. That's great. That's how to build it on the on the hardware side. So, what needs to be done from the level of software? Well, if you come here on this link here, you'll notice that there's Open MPI. We've gone on about what Open MPI is, the open source library. The top 500 supercomputers use it. You know. Can you argue with that? But this is how, as I said, supercomputers are built. This is the backbone of it, and I don't see any different why you would not want to use this methodology, this library, MPI, with C++ in mind, or C, to get the job done. So this link will show you how to build a cluster, or Beowulf cluster, using Linux. Again, this is where Microsoft goes bye-bye, because you'll get killed on the licensing, on the Cal licensing with Windows, and you definitely need something like a Linux, because there's no licensing fee and it's free. You can't blame, you can't go wrong with that, right? So anyways, what you do is no different than with the rest. You set up an SSH server. You have your client, which is basically your master and your node. Each one has their own authentication for validating across your private network. Now, here's your host file that's found on your host system, and then you will also need to install, and I'll show you the Linux in a minute with the Ubuntu. You'll need to install the MPI CC library and all the runtime stuff that comes with that. Okay, and I'll show you that in a minute. Okay, and then you're going to connect through your slaves from the master node through SSH. So you're gonna just do a typical SSH. You can shell into the slave, obviously, which will be defined in your host file. Okay, that is cool so far. So what you then need to do is to set up and run your cluster. Set it up, get it running. Use these two commands on your command line. And then at the same time, you will be developing your code, which obviously this can be put into your C++ program or C, and basically do all this fun stuff, okay? I know there's probably a Rails guy sitting there laughing his head off, but you cannot do this in Rails, sorry. I'm sure maybe you can, but why bother? And then you need to use a special template. I can't remember, I don't know the right terminology. It's just basically a rewrapped MPI C compiler, which is going to basically use GCC, which is obviously standard Linux compiler, and it can support all the commercial ones as well. But you need to use this MPI CC compiler, run it through this MPI run, which will set up the number of processes, and that's all local. I'll make sure of that if you're good to me. And you run it. So that's basically a gist of how everything's done. And these are the examples. I've actually got a posting on all this stuff with other links as well. Now, where does that leave world of HFT, high frequency trading? Well, if you want to go pretty crazy, there are some interesting presentations that you should be aware of. Okay, so this one's from a professor at Buffalo, University of Buffalo, or I'm not sure, but this person explains all the CUDA. Now, yeah, get it, CUDA with OpenMP and OpenMPI, okay? All done in C and C++. This presentation is pretty killer to show you and introduce you to the world of this. And this is how the current generation of high frequency trading platforms are built, used with CUDA. It's an API from Nvidia, and I'll show you that as well. But this presentation goes on about CUDA kernels and how they're segregated with grids and blocks. Blah, 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 blah. Let you read that at your own leisure. And there's certain types of codings that you need to be aware of. So you have all these cores sitting on one computer or one card, like basically a GPU, a graphical processing unit from Nvidia. That's why it's from Nvidia, the graphics card maker. And then here's some example code, all again in C++. I know Fortran support, I'm not sure, I think Java is supported. Don't ask me about .NET, I don't know, and no offense, it's beyond me. Now, where does this help out HFT? Let me just go through this stuff further. When you do your forking for each new process, or basically a new thread by forking it right here, this enables you to launch separate processes. Namely, for instance, could be maybe an insert into your Redis. Maybe it could be a running an R process, like an R script from, again, within your C++ application, hence your high frequency trading system. And then you got all these parallel processes that you can run. Okay, now again, there's OpenMP and OpenMPI, okay, and as well you can bridge your CUDA. Again, you can use the GCC. Some more information. This gives you a very good overview of everything. So you have your MPI job, blah 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 blah. And here's some example code you can play with. And I'm sure you can find some other tutorials. I'm sure, as the famous saying, Google is your friend. Now, continuing along, here's the link on the quantlabs.net site of all those links I was telling you about. What I'm about to show you are the this is the Buffalo University of Buffalo PDF I just showed you. But here's the hardware cards from Nvidia that you can buy. So this one is the comparison chart of what's available currently at the time of this recording of this video. Now, here's the thing. So we got this GeForce GTX 690. It's 64 times the processing power or speed performance. CUDA cores 3072. Wow, that's whopping. You're also getting 4096 megabytes. Okay? And what do you think the price of that card is going to be? Okay? This is the powers that you're getting 3000 cores. Okay? Now, if I looked at that, here's the price. This is in Canadian dollars, starting from this Newegg, $1,000. Really good. Now, here's another one. Next one down, 48 times, 1536 cores, half the RAM as previous. How much is that one going to cost? 200. No, I don't. It's not that. I think it's this one right here. 680. 459. Okay. Let's just make sure that's the right one. The 680. 680. Is that the right one? Yes, it is. Okay. So that's the price from Amazon. $460. Okay. So you're getting a lot of horsepower for pretty kind of on the cheap with Nvidia, and this is with the code CUDA. So let me just show you the Nvidia CUDA API. Okay. So right here is the developer API. Boom. Everything that you need to get you going. And I know it can be done in C++. Okay, but remember it's more for graphical, but you're really getting it for the horsepower of the processing. That's what you care about. So that's with CUDA, and that's the next generation. That's the current big operation of how HFT is running. Again, look at that price, $460. Cheap, man. Alrighty, let's move on. Everybody's been wanting to see some Linux stuff. Okay. So remember, there's our buddy. There's our buddy again. This link right here, tech tinkering. Okay, I've gone through the code. It seems to work. The only difference is I've not set up the slaves. Okay, but I did go through the code. Now I'm in my VirtualBox Linux Ubuntu. Okay, so I got this guy right here running. Now everything's running, gives you full examples of what you need to install on Ubuntu. This one was done on Debian, but it seems to work. But here's how you install your MPI stuff, your SSH, and off to the races you go. And here's your open SSH that you need on your client or slave systems. Okay, now before we get into it, there is a big caveat with this, as there always sometimes is. The program that you're running, in this case, the one that I'm about to show you, this compiled AOut, which is from this test program .c. I'll show you that in a sec. They need to be that program needs to be local on each node. So you're going to have to set up some kind of shell script to copy over manually each install or each new version of your test program, whatever you're going to call it, your C program, manually, or automate the copy of it into your cluster machines. So there is that caveat, but again, you can do that through shell scripting. All right, so let's give this guy a whirl. let's start from here. Now again, I remember I didn't start the SSH stuff and blah blah blah. That pretty well works, but we're going to start here in the Open MPI configuration host file. Let me just show you that. So let me open up another terminal here. Okay, that's where we want to be. Alright, so let me just show you the MPI host file. Okay, I'm more of a GUI kind of person. I'm not a big fan of command lines, to be honest. I just like my my GUI stuff. So forgive me here. Okay, so let me just show you the host file. Here's the host file. That's the same as what we would expect. We compile using remember this MPI. Okay, so let me just go into my workspace where this program is. I think it's Open MPI test, and here is our test program. There you go. There's the same source code. Oh, before I continue, there's some weird compilation error here. It doesn't harm it, but we marked this line out. This RC equals MC MPI get count, whatever. I just want to see this thing run, but there is that strange problem. Anyways, so let me just show you that this runs. There you go, starts working. So if you remember, I told you about the MPI C compiler. It wraps around a certain whatever C compiler. Just do this -show me, and this will tell you it's wrapping against or wrapping around the GCC, which is what we want. And the GCC is the latest one that I've got. No magic there. So it's a 4.52 whatever. Okay, so there's that. Let's do this eval on this SSH, which will just give me the process ID for the SS agent. There we go. We're going to pass the source, that's the password over. I know this does run. Maybe I think I gotta be root. Fat fingers today. Okay, so let me just do this again. Let's see if this runs. Sometimes I get lazy. You gotta set the permissions for the other user ID, but yeah, whatever. There you go. Okay, so what we're supposed to do is SSH into the slave, but we're not doing that. So let me exit out and go back to my other regular caustic ID or caustic user. So we're back to where we were. Okay, so let me just show you. See, when we compile the program, that test program I just showed you, the C program, this is the bin file, what we run. So that's what we're running. I think it's bitching about that there's no processor. Yeah, it's just bitching about it can't get access to one of the slaves. No big deal. Let's see, this probably won't run either. Yeah, it's bitching about as well. Rank, blah, blah, blah. Yeah, I just can't log into the client. That looks like what it is, but I'm not too worried about that. So we know about the program. We've compiled it. Now, remember what I said? The A out is that bin of the test program, or the test C program. So we're going to try to run it. So there you go. It's going to run 20 processes locally. So that's what it did. Okay. And now we're going to try to do it through the cluster. But guess what? The cluster's not active. So that's going to bitch about that. Yeah. So there you go. Yeah, can't find the cluster. See here, it's saying the MPI host file can't log into those slaves. Oh well, life continues, doesn't it? Okay, so that's the end of that. Pretty powerful stuff. Where do we go from here? This is just a demo of what an Open MPI does using the this Beowulf cluster. Seems to work really well. Where do we go from there? I think what will start to happen at some point is we will start to look at the CUDA boards. Okay, now this is where things will obviously become more proprietary. I think the free giving of all these videos and stuff is all fine, but as you know that we are getting into the secretive world of HFT. But this is a good pointer for everybody that's wanting to get into this stuff. So be aware of that. If you are a current member, be proud. It's affordable. I wouldn't be surprised they'll be increasing the rates very fast for the quantlabs.net membership. So join, because this stuff is becoming, as I said, proprietary. And when you start to implement the live trading strategies, especially what's profitable, guess what? You got something very, very valuable. Lots of multi-million-dollar, probably safe to say multi-billion-dollar operations run off of these systems. So what I've shown you is a basic cluster done within the world of C++ in Linux, on the same level as a supercomputer, no different than maybe a Watson or whatever out there. This is pretty killer stuff, and this is the backbone of how HFT operations work, as well as it also includes the CUDA, these guys right here. And the code is not so bad thanks to the PDF that I found right here from the University of Buffalo. So we're going the right way. The march to high frequency trading continues. On and on we go.